Okay, so I'm going to be showing you how to convert between moles and particles, but first I'm going to show you with roses. So let's say you have 3.5 dozen roses and want to know how many roses you have. So you can use the relationship of 1 dozen equals 12 roses. Okay, so we have to convert this to conversion factors, and you can have two conversion factors for an equality by dividing each side by the other. So it will look like this: 1 dozen divided by 12 roses, and 12 roses divided by 1 dozen. Okay, and I said we have 3.5 dozen roses. So I find that sometimes it's easier to look at this type of problems with a chart. So you do a chart like that. This helps you see that 3.5 is on top and there's nothing at the bottom. And when you are trying to find the conversion factor, I always look at what I have and I say, okay, well, I need to make sure I can cancel this out. So what I need at the bottom is 12 dozen roses. So when I look at my conversion factors, this one and this one, I can see that dozens on the bottom on this conversion factor and not on this one. So I need this one right here. I need this conversion factor right here. So I'm going to write out 12 dozen roses, 12 roses, and in 1 dozen. Oh my god, dozen. There you go. So, and this is roses. So when I look at this problem, I can see, okay, well, I can cancel this out and I can cancel this out. And all I'm left is 3.5 times 12 roses divided by 1. So I'm going to multiply across and then divide by the bottom. But anything divided by 1 is still that number. So I'm just going to leave that one out. So 3.5 times 12 should be 42. So I'm going to write 42 roses. Okay. So that's how I would convert between moles. Well, actually not moles. Right now would be dozen and roses. So now how would we do that with molecules or Avogadro's number? So let's look at that. So let's start out with Avogadro's number. So 1 mole of representative particles is equal to Avogadro's number. Okay, representative particles. So if I convert this equality to the conversion factor, it would help me see what I need. So 2.02 times 10 to the 23rd, 6.02 times 10 to the 23rd in 1 mole. Okay. So let's say I have 3.50 moles of sucrose, and I want to convert this to molecules of sucrose. So let's just look first at, so I want to convert it to molecules of sucrose. Okay, first I look at, remember, molecules of sucrose is a representative particle. Okay, so that means this right here should be my representative particle, this up here. Okay, so if I look at my conversion factors, these two, my representative particles on top, this mole, remember, needs to be down here. So this means this is my conversion factor. Okay, so this one's my conversion factor. So let me just copy that. And I'm gonna put it right here. Okay, so that's how it should look. So moles cancels with moles, and then I will multiply this across like that. 3.5 times Avogadro's number. When you type it in the calculator, I want you to keep in mind that this is in scientific notation. So try to keep parentheses with it because it will help a lot whenever you're dividing and multiplying. It will keep that number together. So this is what I mean by parentheses. You're going to write 3.5 times 6.02 times 10 to the 23rd. Okay, and when you type it in the calculator, it's going to look like this. They're going to give you a number that looks like this. Or it's going to give you a number that looks like this. It's going to look like this. 2.107. And then it has an E, 24. That E means it's an exponent. So that means my number is going to be like this. Well, 2.107 times 10 to the 24th. So another thing that to keep in mind is whenever you're doing these problems, you have to look at your sig figs. So 3.5 has 3 sig figs. Avogadro's number, the one we used, has 3 sig figs. My answer over here has 4 sig figs. So I need to round it to the 3. So that means my answer will look like 2.11 times 10 to the 24th molecules of sucrose. Sucrose. Like that. So this is my answer. Okay? Alright. So that's how you will be converting between molecules. Okay. And let's see if I can show you a different example. Let's show you another example. So let's say that I have 4.5 atoms of zinc and I want to find how many moles I have. Okay, so I have 4.50 times 10 to the 24th atoms of zinc. And I want to find how many moles. So moles up here of zinc. So I know down here it needs to be Avogadro's number. 23rd atoms of zinc. Okay. So I know this, just gonna make it bigger. This cancels out and this cancels out. So I can multiply across, right? But this number times 1, it's still that number. So that means mathematically I'm going to divide this number by Avogadro's number. So this is where typing it in scientific notation helps. Okay, let's see how it would look in the calculator. In the calculator, it would go like this: 0.50 times 10 to the 24th. Okay, and then so like this, times 10 to the 23rd. Okay, and this is division. So you were going to divide it. So when you divide it, you get 23rd. You'll get 7.4750830056. But I don't want that number. It's too large, and also it's not correct. So that's why you're gonna look at your numbers. So this one right here has 3 significant figures, and this one has 3 significant figures. Your answer should have 3 significant figures. So my answer will be 7.48, right? Because 5 is, you round it over, of moles of zinc. And that is the answer for this problem. So try out the problems that I will assign to you on Canvas. Let me know if you have any questions. I am here to help you, and I hope this video helps you.